Okay, I am live today talking about TensorFlow, and you may want to guess what I'm going to cover. It's going to be how to use Rust and TensorFlow. So I'm going to take a look here at the bindings. We have TensorFlow Rust. And if we take a look at this, you can see here that TensorFlow Rust provides idiomatic Rust language bindings for TensorFlow, and it's under active development and not guaranteed to have a stable API. So that being said, sometimes you have to take bets on technology, and I really do see a lot of traction for Rust. It just makes sense. And in fact, one of the things I think that's kind of funny is if you look at TensorFlow Python code, you'll see that it actually is more like C++. So when people talk about, idiomatic Python code, it's not going to be TensorFlow. It looks almost like C++. So why don't you just write in C++? That's why I see a huge future for Rust in particular with deep learning. So if we take a look at this, we can see that this crate depends on TensorFlow C API. And in particular, there's a couple dependencies that have to be installed. For example, NumPy, dev, all that kind of stuff, which is a little bit annoying, but not too bad. And so the other things we have to do is we have to add the stuff to your cargo.toml file, and we have to actually add this to the crate root. And then when you build, you can actually go through and run this build command. And then if we want to play around with it, we can play around with it. Now, this is what I'm actually really interested in playing around with today is Rust-based TensorFlow GPU. And so what I'm going to do is go over to, so this is that repo. I have another repo called Rust PyTorch GPU template, and I have GPU already set up. So I already have a bunch of stuff I've been doing with PyTorch. So if PyTorch works for GPU, pretty good chance that TensorFlow will work. And so that's going to be the goal today, is to see if I can get this working in just a little bit of time. And I'm pretty confident. So while this is spinning up, I'm also going to go to another repo I have where I actually have a lot of examples. And I believe that I have an example in this repo, Rust MLOps template for TensorFlow. There we go, TF Rust example. Okay, so I'm going to just riff off of these different things I have cooking here. So this only works on Ubuntu GitHub Codespaces. Let's see, look at my cargo file. So I did this. I have this thing. So this will be good. This will be a good experiment to play around with. So I guess let's look at the source code, what I did before. We got a main file here. Okay, yeah, this looks doable. Let's get a hello world working and then go from there. So first step, what I'm going to do is I'm going to go into this environment and I'm going to say cargo new, and we'll say Rust RTF GPU, just to make it simple to have a namespace. So basically Rust TensorFlow GPU. And there we go. And now I'm going to CD into this to RTF GPU. And then what we can do is actually put those dependencies inside. And so let's just do what they said, which is let's add this, the TensorFlow GPU, which should work because I have GPU enabled. And then we also can look at my other, maybe we just start with that. And let's look at the other example I have here. So I think that should just work. So I'm just gonna copy paste this into my source, and let's just get a hello world working. Now, what I like to do as well is I'm just a huge fan of makefiles. So I'm going to copy a makefile from somewhere, and let's just look real quick. Yeah, that's good enough. So I'll just copy from the root directory. So cp makefile 2 dot. Okay. Now that I've got that, I should be able to just say make format, make sure my code is formatted. Then I like to do make lint, and this just ensures that syntactically the code is correct. So it's like a pre-step before I get to the compiler. I would say 99% of the time, if the lint works, you're going to be in great shape and it's going to compile. And so fingers crossed here. The thing that I'm very, very curious about, because I've actually never done it, is GPU Rust TensorFlow I know PyTorch GPU is amazing. It works totally fine. This will be my first time actually trying to see if GPU works. Now, what I don't know is how to actually target the GPU in the code, or if TensorFlow just automatically knows how to do it. That's one of the things that we're going to figure out in just a second. So it's going to take a little bit of time to get this cooking. What I could do, which is kind of fun, if you ever want to see like what's going on, one of the things you can do is this. You can say du-sh target, and that shows you, look, you can see here, like there's a lot of stuff cooking in my target directory. And then what you could do is you could do this, right? You could do watch command, and this will just, oh, look at this. It is downloading a lot of stuff inside of this directory. So that's kind of a cool little trick that might be worth, pointing out to people. In fact, I could even say like watch build or something like that. And then what I could do is I could say watch du-sh target, something like that, right? Like, and that could give me some idea. But it did pass, so I can get rid of this and put 4 gigs in there. So there's a lot of packages got put into there. So I'm pretty confident this will work. Now, fingers crossed. Let's see. I'll type in cargo run. What happens? So it's going to compile now. And I'm very curious to see how it interacts with GPU. Okay, let's see what happens here. It's compiling. Now, it is interesting that I wonder if there are some ways to make it go faster. So, well, that did work. Now, what I'm very curious about, the GPU enabled version does work. Now, what I'm curious about, did it really target the GPU though? So what I need to do is actually create a new terminal, and I need to throw that terminal up here. And then what I need to do is type in NVIDIA SMI -1 or -L1. So basically, let's look at the GPU monitoring and see if in fact it's going to hit the GPU. And I don't know if it knows enough to hit the GPU. So what we need to do is actually probably dig into this a little bit. So I got it to work. So that's a good sign. But now, can we get GPU working? So let's see. Why does the compiler say it doesn't exist? Documentation. So let's look at some examples here. What do we got going on, for example? So here we go. Update sample images, regression. So regression could be good. There's the model, there's a regression. So OS, train. So let's see here. What do we got? We have a random variable. Oh, actually, this is Python. We don't want that. So we have MobileNet. So how does this work? So this sample image was taken and can be used. There's several ways to verify. One is to use save model, sample image. So it's interesting that I'm not necessarily seeing that many examples, actually. So what does this do? Model addition. So is it that we're trying to figure out how to load a model? Is that what this is doing? Let's see here. Let's look at the documentation. Okay, so these examples folder, a model for writing, and well, that examples folder has very little into it. Here we go. This model supports training. So that's what I'm kind of curious about, actually, is training. And gradient descent optimizer. Well, I mean, let's see here. This might be a place where we could try to use our friend here, Copilot, right? I don't know how smart Copilot is, but what if we said, um, inside of here, and do like script there you go. Train uh, train a simple model uh, using the gradient descent uh, in Rust. Gradient descent in Rust to how about gradient descent for MNIST data set? Let's see, what does it give me? So we can say, we can do this. We can say, pull in MNIST data, use MNIST, and then we can say, build a model. Okay, train the model. So what we need to do is we can just say build a function, a function that trains the MNIST data set. We can say, here we go. Let's see what happens. So we say, so the data itself probably needs to live locally. Now, I can probably fix this. And let's look at this. So we have create a computational graph, create a placeholder, create variables. Here we go, define a loss function. Evaluate the model, and then print the accuracy. There you go. That's what I wanted. So what I need to do is I think I have MNIST data right here somewhere. Yeah, there we go. So what I'm going to do is let's see here. CP PyTorch MNIST data CP-R. I mean, I guess I could symlink it as well, but let's just keep it simple. And then I could say, just make sure that my git ignore never checks in a data directory. Yeah, data. So hopefully that won't get checked in. And what we could do is see if this will actually format. And let's try that. Let's go with this. Train MNIST. Train a simple MNIST data set. And let's put that up here. Okay. Let's do a format. So I'll say make format. Okay, so now if I do make lint, what happens? Ooh. It doesn't have a size. So this could be very, very tedious. Wow, that's a lot of error messages. So use of undeclared crate or model. Model MNIST. So if I say, so what I could do is say load the MNIST data set, which lives in data. MNIST using TensorFlow. TensorFlow data loader. What I don't know I'd have to look through here and find this out. And we can go to the documentation. We can look for, we want to look just for this crate. So search this. And if I look for, how do you look for just this one? TensorFlow, this one. And if we look for MNIST, does it pop up? Huh? Does it actually pop up? MNIST. No, it doesn't. Load data. I do see load data set builder for so we could say load data set. So I don't know how this code would look though using, how about that? Let's try that. What does it say? MNIST load. I don't train a model, train a TensorFlow model. Uses the it keeps wanting to tell me MNIST. I don't know where that is. I could look. We could say crates, and we could look for MNIST. Is that a crate? That's interesting. A simple MNIST parser. What does this do? A crate for parsing MNIST into vectors used by crate programmers. Interesting. Well, apparently this does exist. So let's try it out here. And let's do that. And we can say, hopefully has a little bit of documentation. So we probably need to install indie array as well. So let's do that. Indie array. So I do like this little checker here where it tells me I'm pulling the right version in, which is really cool. And so that looks like that would work. And let's see here, we got train images. So what does this do if we say make format? Make prints, what happens? Make sure I've got TensorFlow here. What else do we have here? TensorFlow session. We have MNIST. So let's see how many errors I have. So, whoa, there's a lot of errors. Field 2. Is that the latest error or is this oh, there we go. This is the latest error. So makeland. So cannot find function load dataset and create MNIST. So I need to look at how he did it. He did something like this. So I'm just going to copy his code, and that might help Copilot get a little bit smarter. So we go back here, load MNIST. Let's see, do that. And we can say, and what we could do is even just recreate this thing, right? Let's just build a function that trains the MNIST data set. See what happens if I give it a prompt here. A computational graph. Find the weights and biases. And the model. Find the loss function. Optimizer. Find the session. Initialize the variables. Model. There we go. That's the model. And accuracy. So let's see what this does. Go here, make format, make lint. So lots of mismatch types. So no method named placeholder. Method not found in TensorFlow graph. So yeah, this might be a little bit too bleeding edge unless I find another example here. Let's not give up yet. So let's just go to GitHub and let's say Rust TensorFlow. Let's see if we find anything. So we've got that. Let's look at the issues then. Let's look at issues. There should be a way to please publish a new release on crates. Oh, I see. Several changes have been implemented. Can we get a new release? So I guess there's a new release here. Let's see like tutorial. Yeah, so this might just be super bleeding edge here. These examples I don't totally get. Oh, I see. No, I do get them. So here we go. What about this? MobileNet. What does this do? So use TensorFlow, create an eager execution, load an image. I see. Okay, here's how we're gonna work on this. Okay, this is like an idiom that I think I've seen with Rust before. So what we're gonna do is we're gonna clone this, and then I'm gonna git ignore it. So this is a better way to do it. We'll go here, and I'm gonna say git clone like that, and then what I'm gonna do is I'm gonna tell my git ignore to ignore this because we're going to use this as like a prototyping library. And so we need to say ignore Rust TensorFlow source code. So we're going to ignore that. Now we're in business because what I can do, should be able to go into, where's TensorFlow? Tree. Oh, that's too much. Say ls-l. Where did it clone that thing to? It's a git clone. Oh, Rust, which is kind of an annoying name. It's a weird name for a repo, but let's cd into Rust, and then what we need to do is go into. Let's double check here. We need to go into examples here. So basically, what we can do is just run it. So we can run the examples by just selecting something like this. And this is something I'm kind of new at with Rust, is the cargo running thing. So you would say cargo run dash examples, something like that, and then you do this example. This always trips me up when people do this with Rust. Oh, okay. So let's do one more time. So it says dash features equals eager. That do. You can just tell it to look inside of examples, And now what I'm very, very curious about here is, first of all, if it compiles, that's good. But I'm also curious about this, the GPU. Let's see if we get lucky here. If we're lucky, we hammer the GPU. Okay, it's building. And let's see what happens here. You can see here it's consuming more and more memory. So this machine has a ridiculous amount of memory. It has 110 gigs of RAM, which is way more than I have on my, $5,000 laptop. Whoa, it's getting really pulling in some memory now. Oh, now it's moving on to MobileNet v3. Whoa. Oh. Okay, so I have to first run Python. I have to first run Python examples here. Which good thing I have. Good thing I have. Oh, I'll just say pip install TensorFlow. About that. So someone asked, how do I know what's being compiled? Well, that's the beautiful thing about CodeSpace is I don't care, right? Because it's not on my local machine here. This is on a cloud-based instance, and if there was some issue with it, who cares? It really wouldn't affect me. And I think that's a great example, actually, of why you should use cloud-based development environments. Okay, so if we do this, what happens? Rebuild it. Downloading data. So it's going to download the weights here. And let's see what happens. Okay, now let's recompile. It's looking, whoa, look at that. Now, did that hit the GPU? I didn't see it hit the GPU, but it does work. So we're able to do a prediction because this TensorFlow binary is optimized, to use the CPU. Now, what I'm curious about is how to enable GPU. So I was able to see load a model and do a prediction, which is awesome. Now, the trick here is I want the GPU. Give me the GPU here. How do I toggle that? Defaults feature. Ooh, do I just say TensorFlow GPU? Is that how I do it? Do I enable that feature? Let's see here. Wow, this is like a super research oriented. I'm learning a lot about cargo. I definitely am not an expert yet, but this looks pretty slick. Did you mean features? Yes, I want to do GPU. Does this work? Let's see if this works here. So if this does in fact work, that's really cool how they orchestrated this repo and shows yet another example of why Cargo has a lot of capabilities that you want with MLOps. Like the fact that I can trigger all these really cool features and like toggle them off and on is just amazing for building high performance tools. So let's go ahead and take a look at this thing here. You can see it's working, right? It's compiling here. So let's see what happens. Hopefully, fingers crossed, GPU just works. Because I do know PyTorch GPU works. You can see it's getting pegged here. We're using a lot of, there we go. Now it's moving on to MobileNet example. Does it work? Did that do anything? Let's see. Cannot open some GPU libraries. I see. Skipping registered GPUs for how to download and set up for your platform. This is really the train wreck of Python. So let's see here, Linux. I mean, I hate Conda. I just absolutely despise Conda. And the fact that I have to actually, that's how they recommend it, is just awful. So, I mean, it's absolutely ridiculous that you have to use two installers in Python. So, for the sake of completeness, though, let's just put install GPU, and let's do that. Let's do this. Well, Rust. Let's look at the refresh. Why do I not see install GPU? That's formatting. Let's try that. Bash install GPU. Who knows? Well, this is one of the issues I have with condos. A lot of times it's non-deterministic. And hopefully people that use Rust will get into not having these weird install dependencies on Python, which is maybe the worst language possible for installing packages. They have competing solutions. But just to see if I can get this working, I'll go ahead and do Conda. Yeah, this is one of my issues with Conda, is just the time it takes is just horrendous. I mean, it's just you're hanging and hanging and hanging. Well, who knows what this thing is doing. It's quite irritating. But if I say here, just look for this thing. This is really the wheel of death with Conda. Is what are you doing? That's the real question. What is happening? It's hanging. It's hanging. I mean, the good news is that I was able to get, in theory, a lot of stuff done because of the fact that I could use those new features. And while this thing's doing whatever it's doing, I'm gonna put this as notes to people so they can reproduce what I did. So I'm gonna go back to here and say, if you want to PyTorch and TensorFlow, let's say say this, say TensorFlow Rust following. Right. We'll say someone should check out this. Check it out. So following. One, check out repo, and two, do the following. Okay. So the world's slowest installer, Conda, is doing its stuff. What does that say? No, I don't want to disable. Just hanging. Yeah, so this is a I would say a minus for TensorFlow here, is that I think the people that are involved with TensorFlow, my feedback to them would be, you know, throw some fresh water on your face and just, kind of rethink things. Why are you telling people to use two completely different tools that actually have massive conflictions to install TensorFlow? Like, why would you do that? Why wouldn't you just give them one method to install? So I think, and also I think this tool has been very slow. So I think this is a weird thing, because PyTorch, you don't need Conda to do GPU. So the fact that they do this dependency is just quite strange. And I think it could really hurt TensorFlow, unfortunately. But let's go ahead and take a look at this. All right. Let's check out this thing, see if it's done. Just the big goal again, can I get GPU TensorFlow Rust? And it's now my fate depends on Conda, which I'm not optimistic, but we'll see. We'll see if this will actually work. It's certainly slow. I mean, that's one thing about installing with Conda. Really hope some Rust people will get pure versions of things, so you don't need to install via other packaging systems. That would be amazing. Hopefully, maybe some big vendors can look into this. But still hanging here, right? This CUDA toolkit here is just hanging and hanging and hanging and hanging. I mean, I guess what I could do in the future is quit complaining, and I could just, while this is what I could do is I could actually compile it myself, which I'm tempted to do actually, is building TensorFlow from source. I might actually just do this. No incorrect. You're using Conda, which I don't like. So I think using basically using recompiling it myself does seem promising, and I might do that. Look at this. Whoa, low disk space. Holy smokes. Done. Well, yeah, I've been doing a lot of stuff in here. Well, hopefully this doesn't blow it up. So it says by downloading, we did that. So now, fingers crossed, does GPU work? Come on, really? So I did all that stuff and still it didn't work because couldn't load dynamic library lib cuda.so. So that's kind of a bummer here. Yeah, and I don't know, cannot open. So I got things mostly working, which was kind of fun. But I'll put a to-do list here for me, which means that what I need to do is this was day one. I need to save for the next time is for day two of TensorFlow Rust. We will say goal, figure out GPU for TensorFlow Rust. So really, really, really close, but not quite. So we'll call it there a day at this, and thanks for all the people that showed up. See you in a couple.